some of the foundation of it. Okay. Scientific notation was created because when you talk about, can we close Chromebooks, please? When we talk about really small things or really large things, and really generally it happens in science, they got tired of writing out all of the zeros, and they came up with an easier way to do it. Okay, and they call it scientific notation. Can somebody think of something really large that we would talk about in science?
Trillion.
An object that's really large. A large object. A black hole, okay. I bet there's a lot of scientific notation written about when I'm talking about black holes, yep.
People in the world.
Number of people in the world, sure. How hot the sun is. How old a fossil is, maybe. Yep, absolutely. Okay. So those are the large things, and they also use them for small things. Can somebody tell me an item that's really small that we might? Atoms. Okay. And really, scientific notation's not as old. It's not that old. It's probably as old as the discovery of atoms, right? They started talking about these really small things, and they wanted a better way to talk about it. So the thing you need to know about scientific notation, it's always a number between 1 and 9. Okay, so I want you to write this at the top. Between 1 and 9. And I kind of hesitate because I don't like that language, but we write it as a number between 1 and 9 times 10 to something. Yeah. In high school, it's probably a good idea to be like, as soon as the teacher's talking, you should already have your stuff ready. Okay. So what do I mean by that? Yeah.
That it has to be through 1 through 9, and at however many square things are off, like the square part, however many that is, that's being 0.
Okay, yeah. So, and we've seen some of this. So if I'm looking at this number and I want to change it to a number between 1 and 9, somebody tell me what that number would be. Yeah. Exactly. So if I want to change this to a number between 7 and 9, I'm going to change it to 7.86. Do you agree that that's between 1 and 9? The biggest point is that there's not more than one digit before the decimal, right? If there's 2 digits there, then it's not between 1 and 9. And then what we're going to do is we're going to say times 10, and then we're going to say this really isn't 7.89. It's a small number. Oh, thank you. 7.86. It's really a small number. So we're going to represent this. When I multiply something by 10, what does it do to the decimal point? Brody.
It moves it one place to the right.
It moves it. Okay. And he said right, and I didn't even want to be that specific. So if I have 5.25, if I times that by 10, it moves it one decimal place. If I times it by 100, it moves it 2 spaces. If I times it by 1,000, it moves it 3 spaces. This got moved 1, 2, 3, 4, 5, 6, 7 spaces. So we're going to write a 7 up here, but it's a small number. So we're going to put it as a negative, means that it was a decimal. When you get to chemistry, there are numbers that you're going to deal with that are written like this because they're really small things. I don't think it works. The next one, change this number to a number between 1 and 9. Yeah. So all we're doing is taking the first digit and putting a decimal behind it. The first non-zero digit. And then I'm going to say times 10. I don't need this 0 because a 0 on this side of the decimal means nothing. So I don't put it there. I'm trying to write this as small as I possibly can. How many spots did the decimal move?
Three.
3. Is it a large number or a small number?
Large.
It's a larger number, so this is a positive.
Why don't we just keep it that normal?
I'm sorry?
Why don't we just keep it 3,940 normal?
Yeah, great point. This number here, we would probably not write in scientific notation.
Let's do one more.
Okay, but it's a good, good point. It's a good warm up. It's just to show you can. The funny thing, people love playing tricks on each other. You can turn this calculator to always answer in scientific notation. If you do that, then 30 will be read as what? 3 times 10 to the first. Every answer will be written in scientific notation, right? So then they'll have to translate. Okay. Let's do one more. Which of these 4 do you want to do? Someone on this side of the room. Looks 3 is confusing. I appreciate that. Write it as a number between 1 and 9. 4.7 times 10 to the 0. What is raising something to the 0 power?
0.
No, it's 1. So timesing it by 1 is what? The same thing. Okay. We feel comfortable with those? Okay. Now write in standard form. So go the other way.
What? I don't remember how to do that.
He's wild.
It's like the highest number for,
Yes, highest number.
or the highest, like, yeah,
Oh.
or it's the original form, I guess.
Here's where people get confused. They want to say that means it's got 3 zeros. It doesn't mean it's got 3 zeros. It means what? It moves 3 decimal places. Do you see that I moved it 3 decimal places? Bless you. Can someone give me this answer? How many zeros will this have?
6.
4, 5. 4. Oh,
It'll-
wait, my bad, I thought we were doing 8.
It'll have 4.
Oh, wait, yeah.
And really weird thing, if you ever traveled to Europe,
No.
they use commas as decimal points in Europe. We use them for every 3 digits.
Oh, that's
In Europe, they would write this as 7.31 times 10 to the 6,
Oh, no, I don't like that.
or $5.25.
I don't like that.
Wait, so how would they write? How do they know what 1,000 is? They just don't. Like, how do they know what 10 billion is? They just don't.
They don't count that high in Europe.
What?
So how do you get $10 billion?
We're smarter, that's why.
Can somebody tell me what this answer
Where did you get $10 billion?
is? 0.0067.
Can we do 10 real quick?
Can we do 10 real quick? How many zeros is this going to have? 7. Because it's going to get 1 is going to move for the 5, and then 7 more.
I had the same thought.
Can you sit down, please? And I like to write these in groups of 3 just so they're easier to see. So 1, 2, 3, and then like a little space. So there's 6, 7. It's kind of nice to write it that way so it's easier to see. Okay. So it's all about move the decimal in which way. If it's a negative, it's a smaller number. If it's a positive, it's a bigger number. Okay.
Is that why Desmos doesn't put the commas and they just put the spaces?
Yes.
Yeah. So it's easier to, because of Europe? Probably not.
Wait, so what if you have like $10 billion in your life and just like you have infinite money?
Yes.
They don't count that high?
No. Yeah. You know I'm joking that they don't count that high.
Wait,
Do you really think that? Yes.
I don't even remember him saying that.
Okay. Write each number in scientific notation. So here's an answer that a student gave me. I mark it wrong, and they're like, it's totally in scientific notation. It's times 10 to the 6. What's wrong about this answer? It's less than 1. We need to change it to what? To 2. So this should be written as 2. Here's the question. Did the point 2 borrow a 10 or to give the 10 to the other thing? It borrowed a 10. So if this guy needs a 10, he took it from here. So now this is 10 to the 5th. This one. Actually, I'm going to do one of these. Which of the? I'll do this one. This one needs to become what? 2.88 times 10. It's giving a 10 to this.
Wait, how do you know if it's giving?
Negative 10.
I'll answer that in just a question. Here, just a second. It would be -8. If you give something negative a 1, it becomes less negative. How do we know if we're giving or taking? This guy is not big enough. So he needs a 10 to become a 2. This guy's too big, so he's going to give a 10. Okay. Good question. I am really conflicted on how to teach you this next part. What operation are we doing here? Multiplication. We are multiplying.
What?
That's definitely.
You should look up and like not be like,
Well, it earned you,
pay attention.
Parker.
I think that's another point.
Do you know what rhymes with attention, Parker? Homework rhymes with attention.
No detention rhymes with detention.
No, what rhymes attention?
No
Detention.
Thank you, detention.
What is a detention? I've never had that.
Would you like to find out?
Nope.
Oh.
I won't be here today.
I can't.
I won't be here tomorrow.
Is that why you guys are misbehaving? You're not going to be here today?
I won't be here.
Huh?
Do you do tomorrow?
I won't be here tomorrow.
He's not going to be here for the rest of the
What do you guys say when someone challenges you?
You said
Detention.
accepted.
Bring it
No.
on. Say detention.
Don't you say bet,
Say bet.
bet or
I'm game.
cat, right? Bet.
Yeah, say
Challenge accepted.
He's
So-
under challenge.
Yeah, when
I'm
someone
striking
says
you off.
Oh, you're going to be here tomorrow?
Yeah, no.
You can't pitch from the office.
Yes, I can.
Maybe
I'm gonna
pitch,
tell him what you-
bet,
throw a strike.
challenge accepted.
Give him an attention. He's asking for it.
He is asking for it.
No, I've actually never gotten.
Something.
I've never
I've
gotten
actually
it.
never gotten.
I wish I could say the same.
Just a little taste. I like get it because it's all lunch.
All right, so
Alright, guys, lock in.
here's something we need to know. When you multiply 10 times 10, that equals what?
100.
100, or, attention please, or 10 to the second.
Yeah. Close your eyes.
That's just.
I tried to do.
Y'all are so loud.
Yeah, guys, focus. Jasper, tell them later. So 10 times 10 equals 10 to the second.
Yeah.
10 to the third times 10 is 10 to the fourth. 10 to the seventh is 10 to the 10th. What is the operation that happens here when we multiply? You're adding the exponents. We've done this with variables, okay? So we should be able to do it here. So what am I saying here? Because these are multiplied, then we're going to end up just adding the exponents. So when you, so really the rule should be 10 to the A times 10 to the B equals 10 to the A plus B. So that means on this one, what you do is you multiply, the numbers get multiplied, and the tens get multiplied. So I don't know about you, but I guess I could probably do that in my head or figure that out by writing it out. But 5.4 times 7 is 37.8 times 10 to the negative 1 when I add those powers.
You add that.
Wait,
You don't multiply them.
You add the powers. That's what that's this explanation over here.
okay.
Okay? So we add those powers. This says write your answer in scientific notation. I would mark this wrong.
What?
What would be the way I need to write it?
Because it needs to be.
Oh, it needs to be 3.78.
It needs to be 3.78 times 10. Did I borrow one or is it the 37 giving a 10? It's giving one. To write it in scientific notation, you have to have that 10 to the some power, even if it's 0. This is what your calculator would put out if you put it in scientific notation form. Even this number would give you a times 10 to something.
What if we put up the thing in parentheses? What would it say? Just unable to do it.
It would, so that's where we'll talk about that in a minute. Okay, you're asking the question that I was going to ask in a minute. Okay, so what happens with this next one? This one I can do in my head. 6 times 4 is times 10 to the 5th. I can't leave my answer like that. 2.4. Did it borrow a 10 or is it giving a 10? So that changes it 6. I don't want to do this one.
I don't think we have to. I kind of understand what it is.
Okay, but tell me what the power is going to be. Negative 9. It'll be 10 to the negative 9 when you add those.
Yeah.
Okay.
Cool.
So goodish there. Okay. Now we're going to talk about adding and subtracting. So this is multiplication. And multiply has this rule where you add the powers. If I'm not going to write this, I don't want you to write this down, but if I said 3 times 10 to the second plus 2 times 10 to the third, why doesn't that equal 5? Because this is a what? Tell me what that is in standard. 300. And this is
2,000.
2,000.
Yeah.
When we learned how to solve, or when we learned how to add, we learned that we had to line up the decimal points, right? So the decimal points are essentially lined up. So then this ends up being 2,300. So why can't I add these? Because the decimal points are not lined up. If I change this to a 20, I'm only allowed to do that because I'm going to do what?
Take it down to 2.
I'm going to borrow a 10. Now that these are both the same powers, that lines up my decimal places. 3 plus 20 is 2 times 10 to the second. These stay the same.
It's kind of like
Wait, what? You just added them.
So, and then my final answer would be that. So if the powers are the same, you're allowed to just add them. It's like 4,000 plus 5,000 is 9,000, right? So this first one here, you're going, Mr. McConnell, the powers are already the same. So
7.4
times 10 to the third. The powers are the same. So this and this end up giving you the same thing. All I had to do was add. So as soon as they give you one like that, they take it away, right? So I'm going to actually have us change this. Let's change this to a 3 right here. Okay, and because that's to the power of 3, I'm allowed to what? Add it. So 2.4 times 10 to the third, or plus this is just 7.97 times 10 to the third.
Wait, how'd you just like?
I changed the question.
Did we give them?
Oh,
I changed the question.
Did we take or did we give?
We didn't do either. I just said, pretend like this question was different.
I would change it.
Yeah, sorry. So, if they aren't the same, we have to make them the same. So, in other words, I don't want this to be what I have here. I want this to be both of them 10 to the first. So, if I'm going to make this 10 to the first, that means how many zeros are going to be given to the other thing? 3. And now I'm allowed to add them. What is 2.5 times 6,140? No, I'm sorry, plus.
6,142.5.
I want the answers in scientific notation.
We need to make it 6.1425
Times 10 to the negative.
4. No, there you go. What you're giving?
I don't know.
You're giving.
So what's it going to be?
Negative 2. So it'd be 5. Wait.
I haven't heard it yet.
3, so it's 4.
It's 4.
Sorry, I wasn't even looking at that.
Because it went 3 spaces this way, so it gives it 3 tens. There's already one there, so it's to the 4th. It's not negative. These are big. That's a big number, right? Okay. So let's talk about this is where it gets really confusing. So we got to get them to match. So this is really 5, because these were all positives. Powers. It's moving. If I make a number smaller, if I had 6,000, that's 6 times 10 to the positive 3. If it's 0.0006, then that's 6 times 10 to the negative 4. Okay. So we want to get these to match. It doesn't matter which way you move. I can either make this one here 10 to the negative 6, or I can make this 10 to the negative 3. Okay, so if we try to make them both 10 to the negative 3, I almost recommend just making it. That means this is giving it what?
Negative 3.
Negative 3. It's so 3 tens, negative 0.0033. So then it's 5.0033 times 10 to the negative 3.
It's already inside.
And it's already in scientific notation.
It's actually not that challenging. It'll get harder with this.
It does it just gets confusing when you switch back from multiply and adding, but not really. I mean, huh?
Like, you have to multiply and add the same thing.
You maybe, but
That'll be like one thing.
so let's do one more. This time it's subtraction. So again, we're allowed to subtract as long as the powers are the same. So do you want to change it to 10 to the second, or do you want to change it both to 10 to the fifth? 10 to the fifth. 1.39 times 10 to the fifth. I always like to just write 10 to the fifth right here and figure out what I need to do. It took 3 away, 3 tens.
Negative 7.
No.
No,
It's the decimal movement.
You're moving it.
How many spots are we moving it?
You're
Giving three, so we-
positive three.
So if we're giving 3, we're taking 3 spots away from this. No?
Oh,
0.004. Okay. If I take tens from here and give it to there, taking tens away is going to make this a smaller number. So now if I add these, I get 1.394 times 10 to the, oh, I'm not adding. I'm sorry, I'm subtracting. So once they match, I can go to my calculator and I can just say 1.39 minus 0.004. Thank you. 1.39 minus 0.004. And we get 1.386 times 10 to the 5th. If we had more time in the year, I would not show you this next thing until after the group quiz. Okay. So if I go to Desmos, first of all, when I times large numbers, it'll give me that result. But if the number is big enough, it might just say, you know what? I don't want to give you all those digits. It gives me what? Scientific notation. Have you ever had it give you scientific notation? You're like, what's going on?
And then in on the honor reading guide, it also teaches like I don't know, it always says don't make this not scientific notation. I never know how to do it.
Right. So if this was our answer and we don't want it in scientific notation, then what do I have to do? I got to move the decimal 10 spots. Right? So it is allowed, we're allowed to put in scientific notation into the calculator. Here's something that's weird. When you get to this calculator, scientific notation looks different. So if I do that same operation, times 1, 2, 3, 4, 5, 6, it gives you, I don't know why, but a computer scientist decided to make it an E. So it looks like error, but that just means scientific notation. That means 10 to the 10th. You'd write 10 to the 10th. Yeah, I don't know. It is tempting to just make it that way. So my point, though, with this is if I wanted to do number 9 from my worksheet, I could type in 1.39 times 10 to the 5th. Oh, yeah, I know. I got to fix that. Okay.
Is there a way to just have it in standard form?
I don't think so. It automatically gives you the form it thinks it wants to give you. So you need to be able to interpret it. But so here, there's that number, and actually it's giving me in standard form, minus 4 times 10 to the 2nd. And we said the answer was 3.86 times 10 to the 5th, and that's the answer that they gave us, just not in scientific notation. My point being, for all of these ones where it says multiply or add or subtract, you can simply just type them in the calculator and it gives you the answer. There's no reason not to type it in a scientific notation. Yeah.
Like sometimes when you type it, I don't know how when I type it in, it just gives me the actual scientific notation.
When the number's really large, it just automatically gives you that.
Okay.
When the number's not very big, they're just saying this isn't that big. So I would have to, because it wants in scientific notation, I'd have to convert this back. Okay. But if this was like 10 to the 25th, and this was also to the 25th, then all of a sudden they're answering in scientific notation. Okay. So I want you to be able to struggle through and do all this work to figure it out. But I also want you next year to be able to go, oh, I can just type that in the calculator and I can get correct answers.
So do we need to show them what kind of group quiz?
I don't care. Okay. So I'd like, yeah. Now here's the thing. If they're like already matching, which none of these are, they're already matching, then hopefully we can just quickly do it, right? Like typing this in the calculator is going to take a lot more time. Okay. So where's the group quiz? There are two parts to the group quiz. Today I'm giving you the first part, and on Monday or Tuesday I'm giving you the second part. The first part is the rest of these questions. Yes. So if you want to start working on them, if you want to challenge yourself to do them without the calculator and then check them with the calculator, if you want to use the calculator, I'm sorry? All the questions, yes,
On both sides.
on both sides.
Oh, that's fine.
You literally can just give me answers. Well, no. Which one? Oh, on the back side? Yeah, you can just write down whatever it gives you. I just want you to be able, I want you to show me that you can work with scientific numbers, scientific notation, and answer in scientific notation. Make sure you answer the questions in scientific notation. It could be 5 times 10 to the second. Yeah.